In this video, I will show you how to graph this really cool piecewise function. And in the end, we will describe any points of discontinuity that show up. So let's get started, and we'll just take it one piece at a time. Let's start with this piece of the piecewise function. For this piece, the domain is that the x values have to be less than or equal to 0. So let's take that information and use it as we make our table of values. So less than or equal to 0, so that means that we will start with 0 because of the equal to 0 part. And we will go less, so 0 and -1, -2, -3. Let's see how that goes. Now, the function is negative x squared plus 4. So if x is 0, 0 squared is 0 plus 4 is 4. Now, what if x is -1? Remember that you have to square it first and then apply the negative. So -1 squared is +1. So this becomes a +1, but then the negative comes on it because of this. So it actually becomes a -1 plus 4, which will give us 3. All right, normally we would just do this in our head, but I feel like I just need to show you exactly what's happening. If x is -2, just look at it another time. So we have -2 squared and then plus 4. This will become a +4, but because of this minus sign, it's really will become a -4. So we have -4 plus 4, so that's going to be 0. All right, I feel like I'm just going to do that one more time, and then I'll just erase all this stuff. So let's do what happens if we have -3. So -3, so we have -3 squared plus 4. So that's going to be -9 plus 4. So that is going to be -5. All right, because -9 plus 4, that's going to be -5. I feel like we have more room. So I want to see what happens at -4 actually. So I will have negative and then -4 squared plus 4. So that's going to be negative, and then 16 plus 4. So that'll be -12. And that will be off the graph, so that's just 1 point too far. So let's just wind it back, and this is going to be enough. So as we do this graphing, remember that we're dealing with a parabola. So and because of the negative sign in the front, we're expecting this to be some type of an upside down parabola. So that will just mentally guide you as we plot these points. So 0, 4 would be right here. -1, 3 would be right here. -2, 0. Okay. And -3, -5 would be right here. Okay, so you can see that this is part of an upside down parabola, so we'll just draw this as best we can. But the idea, okay, I missed. Let me try that again. This is very difficult with a digital pen, you guys. So I'm just doing my best. All right. So that is the first piece of our piecewise function. Let's go down to the next piece. This is an absolute value function, so we're expecting it to be some part of a V shape. So just keep that in the back of your mind. This is a V shape. The x values go from 0 to 4. So as I make my chart, okay, with my x value and my y value, I'm going to start at 0 and end at 4. So we'll have 0, 1, 2, 3, 4. Okay, so if x is 0, that's 0 minus 2, that's negative 2. But then, of course, the absolute value of negative 2 is positive 2. All right, if I put 1 in there, that's 1 minus 2 is negative 1, but the absolute value makes it a positive 1. If I put a 2 in there, 2 minus 2 is 0, and the absolute value of 0 is still 0. If I put a 3 in there, 3 minus 2 is 1, absolute value stays 1. If I put 4 in there, 4 minus 2 is 2, absolute value of 2 is still 2. Okay, notice that at 0, it says 0 is less than x. It doesn't say less than or equal to. So that tells me that 0 is going to be an open circle. So 0, 2 is an open circle, all right, not included in the actual graph. Then I have 1, 1, 2, 0, 3, 1, and 4, 2. Okay, now 4, 2 is going to be a closed circle because of the or equal to sign. X is less than or equal to 4. That means the 4 gets included, so the point 4, 2 will be a closed circle. All right, so we'll just connect the dots, and that will be it for this piece of the piecewise function. All right, let's switch over to the third and final piece. Okay, x minus 5 to the third power. X to the third power is the parent function, and remember that a cubic function has this general look to it. So it's got an inflection point, it's like a swerve. Just keep that in mind as we are graphing these points. Now let's make our table. All right, we need x values greater than 4. Now it says greater than 4, but I'm actually going to start with 4. And because it's not equal to 4, that just means that this will be an open circle. Whatever I get here, when I graph it, it'll be an open circle. All right, so even though it says greater than 4, don't start at 5. You still have to start at 4. But because it says greater than 4, then I will go like 5 and 6. Okay. That's a horrible 5. Let me try that again. Okay. So let's put a 4 in here. 4 minus 5, that's negative 1. All right, so I'd have negative 1 to the third power. Negative 1 to the third power is still negative 1. Let's put a 5 in here. 5 minus 5 is 0. 0 cubed is still 0. Let's put a 6 in here. 6 minus 5 is 1. 1 cubed is 1. Let's go for 7. Let's see if 7 will fit. 7 minus 5 is 2. 2 cubed is 8. So we will have 7, 8. All right, that's as far as we can go. Remember, this first one is going to be an open circle because it can't be equal to 4. So 4, negative 1 needs to be an open circle. And then we have 5, 0 and 6, 1 and 7, 8. 7, 8. All right. Now, I'm looking at these 3 points, And if you had no context, if you did not know that this was a cubic function, you might think that this is just going to go past like kind of straight through these points and then go up like that. But that would be wrong, because we know that a cubic function, if you just focus on the parent function, x to the third power, it goes like this. It goes, see, think of that as half of an upside down parabola, and think of this as half of a right side up parabola. All right, it's sort of like you took a parabola, a regular parabola, but then you took the left side and you flipped it down. So instead of being up, it went down. And that's how you get the cubic shape. So upside down parabola, right side up parabola. Normally, this happens right at the origin. If we were talking about the parent function x to the third power, this point of inflection would be right at 0, 0. Because of this minus 5, we know that that means that everything is shifted to the right 5. So if we just take that point of inflection and move it over 5, boom, that's this right here. So that tells us that this point, 5, 0, is the inflection point. So when we graph this, we should be doing that half of a parabola starting from here. So this should be curving upward, like an upward curving parabola like this. All right, it should not be like a straight line. And then this, the other side, all right, if I were going to draw the whole thing, all right, it would be like this, all right, half of a downward facing parabola. So that's what I'm doing. You're not going to see much of it because I'm going to stop early. All right, so you're just going to see that little part right there. But this should not just go straight through. It should be curving down and then curving up. But that's it. So we did the graph. We have now graphed the piecewise function. Now it's time to talk about points of discontinuity. A discontinuity is a break in the graph. Both of these discontinuities are jump discontinuities. There are 3 types of discontinuity. There's a jump discontinuity, which looks like this. Okay, that's what a jump discontinuity looks like. There's a gap. Another type of discontinuity is a removable discontinuity. A removable discontinuity is basically a hole in the graph. It's a single missing point. All right, this would be a removable discontinuity. And the other kind is called infinite. An infinite discontinuity is when you have an asymptote. Okay, so maybe one part of the graph is going like this, and another part of the graph is going like this. All right, and the graph is split apart by an asymptote. This is an infinite discontinuity. Now, I see that we have 2 breaks in the graph. We have one break right here, and we have another break right here. In both cases, we have a gap, so this is a jump. These are 2 jump discontinuities. We're going to mention the x value of it. So we have a jump discontinuity at x equals 0, and we have another one at x equals 4. Okay, so we have a jump discontinuity at x equals 0, and we have another one at x equals, what did I say? 4. Yep, right there. All right, and that is it. That is how you graph a piecewise function, and that's what discontinuities are.